Hi, I'm the Mad Computer Scientist. On this channel, I discuss math, computer science, and technology topics that are of interest to me. If you're expecting a lab coat, I'm sorry to inform you that computer scientists aren't that type of scientist. We don't really do that type of experiment anyway. However, let's get into something before we begin the topic of today's video. This is the standard YouTube stuff, but it does help the channel grow. Please be sure to like, be sure to subscribe and ring that notification bell so you will always receive the latest updates. And please be sure to leave a comment below. Also, share this content out to your friends and family, or share it out to people because you think it will annoy them. As long as it pleases the YouTube algorithm, we're okay with how we get the views. Today I'm going to talk about AI hallucinations and why they occur and the ways we're going to mitigate them, or at least hope to mitigate them in the future. Now, the main reason why AI hallucinations occur is because they pull their information from the internet. And as we all know, the internet is an absolutely accurate source of information all the time. For example, you could not go to Twitter right now and find dozens of people offering contradictory opinions on the same topic. Now, of course, I'm being sarcastic because the internet does not always provide accurate information. Anyone can publish on the internet. And because it's pulling from a large set of data, which can have over 2 trillion data sets, it's going to pull errors from that as well. Not to mention, a lot of people misunderstand what these large language models are designed to do. Basically, they use something known as an autoregressor to come up with probabilistic predictions of what the next word in the sentence will be. Sometimes they do this based solely on the prompt, and sometimes they use algorithms that can actually build on each word in the response in addition to the prompt. Now, this does take a while, but fortunately, the companies that run these models have large data centers and thousands of servers which can provide relatively speedy results, even though it's slow computationally. And if you go through exactly how these work, or at least as close as you can get because most of these models are closed source and we don't know exactly how they work, you'll find out that what they are doing is a chain of NP-complete algorithms. And if you don't know what NP-complete means, please check out my video where I explain briefly big O notation. Go back to autoregressive generation a bit because I noticed I got a bit carried away and expected people to know as much as I do about this topic. And of course, when it comes to autoregressive generation, that amount is nothing since I just looked it up on IBM.com. They say that autoregressive generation is a machine learning technique most commonly used for time series analysis and forecasting that uses one or more values from previous time steps in a time series to create regression. I know that didn't really clear things up for most of you, but all it's saying is it's working step by step to come up with the answer. And each step kind of changes, depends on what happened before. Okay, now that we've discussed why LLMs hallucinate, let's discuss how we can prevent it. One way we can prevent it is to use high-quality data. Software engineers and computer scientists have realized that one way to help prevent LLMs from hallucinating was to simply use better sources of information rather than using the high-quality, always accurate source of information known as the internet. We all know people are never wrong there. Now, you might be forgiven for thinking that this actually reduced the problem. And it did reduce the problem, but if you're thinking it eliminated the problem, you would be incorrect. As any teacher knows, even the best students will sometimes get answers wrong, even if the teacher told them information that was 100% factual. So because this did reduce the problem, but not far enough, other methods had to be sought. Let's go into what some of those other methods were. One of the newer methods that can help reduce the hallucination rates of large language models even further is a technique known as retrieval augmented generation, or RAG for short. Using RAG, the LLMs will use their training data, but they will also be able to train themselves on the fly by going out and finding additional information to augment their original training data. This serves as a kind of on-the-fly fact-checking, and it reduces the hallucination rates even further. Now, this doesn't even address all the copyright issues that surround large language models and generative artificial intelligence, because, of course, as we all know, these companies have been ignoring copyright issues, and of course, a number of people have tried to find ways to combat AI sneaking into their data and trying to steal it, and that will be the topic of another video. However, while RAG is a good technique that is actually effective at reducing hallucination rates, it does not entirely eliminate the problem. And one problem that occurs with all large language models is because they are designed just to predict the next word, they don't necessarily understand the properties of things when they're describing objects. So someone at the California Institute of Technology, whose full name was not given in the source I'm linking below, I'm sorry about that, has actually decided to work on ways of training the data using only factual information it gives it and also smaller data sets. It's also trying to make sure that when you ask ChatGPT, for example, to describe tennis, it gives you more than just understanding the theories and rules about tennis. It's telling you that it knows actually how to play tennis, even if these large language models, being simply bases of code, cannot play tennis themselves. This is an emerging technique, and it's unknown exactly how this will play out in the future, but it is a promising area of research. I would like to thank everyone for watching this video. Please remember to like, comment, and subscribe. Share this video out. And finally, go out and write some code.